Hello IP students, today our topic is software engineering, and in this lecture we are going to discuss some terminology regarding to software engineering as well as software development lifecycle. So first of all, what is software engineering? Actually, software engineering is a combination of two words, software and engineering. The word software is a collection of integrated programs, or we can say that collection of programs is called the software. Program it is itself a collection of different instructions, and software is a collection of different programs, or we can say that it is a collection of integrated programs. And engineering, on the other hand, is all about developing product using well-defined and scientific principles and methods. So using well-defined scientific principles and methods, if we develop different products, then it is called the engineering. Now what is software engineering? As I told you that software engineering is a combination of two terms, software and engineering. So according to IEEE definition, software engineering, which is a standard definition, the application of a systematic, disciplined, quantifiable approach to the development, operation and maintenance of software, that is the application of engineering to the software, is called software engineering. And another definition, software engineering is the establishment and the use of the sound engineering principles in order to obtain economically software that is reliable and work efficiently on real machine. So we can say that software engineering is all about developing software in cost effective manner, or in within certain time limit. So to develop a software within a certain time limit and cost effective manner in a well-defined approach is called the software engineering. But if this definition is asked in exam, so you have to write IEEE definition, which says that the application of a systematic, disciplined, quantifiable approach to the development, operation and maintenance of a software is called software engineering. Now this is the part of a software products. So we can design, analysis. First one is actually requirement, then system analysis, then system design, maintenance, update, deployment, testing and code design. So these are the different software products. I repeat it again: requirements, software analysis, system analysis, or system or software. Actually software or SDLC refers for system development lifecycle as well as software development lifecycle. Both terminology are used interchangeably, and because the process of developing a software and developing a system are very much similar to each other. Actually software is itself a system. So here if system appears in place of software, that doesn't mean that it is a different thing, it is same things. So system analysis, system design, maintenance, update, deployment, testing, code design and requirement. So now uh, why is software engineering required? So there are a few points that according to which we can say that the software engineering is very much required. It basically manages large softwares. To manage a large software engineering is required. If you want to build up a large software, you want to build it build within a time and in a cost effective manner, and in such a way that no bugs or errors will be raised in future. So to manage large software engineering is required. Second, more scalability. Third, cost management. Fourth, to manage the dynamic nature of software. And fifth, the quality management. Basically all these terms are belongs to the definition of software engineering. Why software engineering is required? So the answer is hidden in the definition of software engineering. If we want to create a software, a good quality software within a time, a particular time limit, in a cost effective manner, and good quality of software, with best approach, then software engineering is required. So software engineering is required to manage large software, for more scalability, for more range, for cost management. And because if we in starting if software in the starting phase, if software has certain cost, and after certain period the cost changed, then customer refuse to pay the extra cost. In that circumstances, it is very difficult to manage or to build a software. So all these things are the part of software engineering, to how to build a good quality software within a certain time limit and within and in a cost effective manner. So different approaches are followed in software engineering. And to manage dynamic nature of software, dynamic nature means if something changes uh, according to time or in future, then these change can also be reflected in our software. So these these things can be managed using software engineering. And last is for quality management software. Good quality software is the main aim of software engineering. To deliver a good quality of software is the main aim of software engineering. So that is also a very important point. So we can summarize it, or can we say that software engineering is required because we want to manage large software, and we want more scalability, uh, cost, and it manage cost of our software. And with the software engineering, uh, dynamic nature of software can be maintained, and it gives us a good quality software. So these are some important points regarding to software engineering. Why is software engineering required is a it is the answer of this question. Next, importance of software engineering. So why software engineering is required, we discussed in our just last question. And in this question, main point is importance of software engineering. So there is a graph which shows the importance of software engineering. First point is reduce complexity. So it reduces the complexity of our software. Second, it minimize our software cost. Third point is handling big projects. So it is useful to handling big project. If we handle a big project, we if we handle a big project, we require particular procedure or some models of software engineering to develop a particular type of software. So it is very useful to handling big projects. And effectiveness, it is effectiveness, reliable software, and decreased time. These are the other importance of software engineering. With software engineering, we can get a software in a very effective manner, and software must be reliable after the follow up approach of software. After we when we follow the approach of software engineering, and it will decrease the time of software when we follow concept of software engineering. So these are the some important points regarding to software engineering. Now, characteristics of a good software engineer. A software engineer is an engineer which is basically design, develop, test, maintain a software. A software engineer is not only a single person who develop a software, but all those person who can participate in the life cycle of a software are called the software engineer. For example, if a person write a code is also a software engineer. If a person who can test a particular type of software, also known as tester, is also a software engineer. A person who can design the blueprint of a software is also called a software engineer. So software engineer is basically a very broad term in which designer, programmer, tester, analyst, all these are the part of software engineers. So what are the characteristics of a good software engineer? First one is exposure to a systematic method, familiarities with software engineering principles, good technical knowledge of the project range, good programming abilities, good communication skills. And these skills comprise of oral, written, and interpersonal skills. high motivation, sound knowledge of fundamental of computer science, intelligent, ability to work in a team, and discipline. So these are the basic characteristics of a software engineering. So first point is exposure to systematic method means a software engineer must follow a systematic method. Otherwise, uh, he will not able to design or develop a good quality software. Then second point is good technical knowledge. So it is a very important point and very quite obvious. A software engineer should have very good technical knowledge of project and also have good programming abilities. If he had not good programming abilities, then there is a problem. And he must have good communication skills, and skills in the forms of oral, written, and interpersonal skills, because um, finally uh, there is a communication between a customer and a software engineer, the what type of software he need. So every time software engineer wants to communicate to a person or a customer, or we can say that end user, that what is the functionality of a software, he basically trained or end user the functionality of a software. For this purpose, he should have a good communication skills. And for customer, if a customer says that he wants particular type of functionality in a software, then software engineering must be in must software engineer must be able to communicate to customer to mention that what type of functionality should be in there in the software, or what is the, and he should able to know what is the actual requirement of the software, and according to that, uh, with with his communication skills, he can deliver his thoughts to customer or end user. And high motivation, actually software design a software is a teamwork. So software engineers is not only a single person, he has some team. So uh, if he itself a high motivated person, then only can he can do a work. And then sound knowledge of fundamental of computer, and he should have sound knowledge of fundamentals of computer science, of course, because software engineering part of computer science. And then intelligence, and then ability to teamwork in a team, and discipline. So these are some basic features of a software engineer. Next is software requirement specification. It's a very important question. It is also called as SRS, and it is so many number of times asked in examination that what is SRS, or what do you understand by the term SRS. SRS basically refers for the software requirement specification. So what is software requirement specification? In brief, if we can say that it is a type of documentation. So SRS is nothing but only type of documentation regarding to a software. So it is a type of documentation regarding to a software. So first point is SRS is a formal report which acts as a representation of software that enables the customer to review whether it SRS is according to their requirement. SRS is a formal report. So first point is SRS is a formal report. So every software engineer read the SRS report, and some of them can participate to make a SRS report also. So SRS report is a formal report, and it is a basically representation of software that enables the customer to review whether its SRS is according to their requirement or not. So SRS decide whether the software is according to the requirement of the customer, or whether it is not according to the requirement of the customer. And the second is it comprises user requirements for a system as well as detailed specification for the system requirement. So in SRS report, basically there is a written work for system requirement regarding to hardware and softwares. And third point is the SRS is a specification for a specific software product, program, or a set of applications that perform particular function in a specific environment. Or so in SRS, so a specific software product, program, or set of application can be mentioned that what type of functionality they can perform. So these all types of documentation are a part of SRS. So in brief, we can say that SRS is basically a formal report which is very useful to decide the user requirement, or basically it contain detailed specification of the system requirement. And SRS report also contain program or set of application that is very useful to decide the functionality or define the functionality of particular program, particular section of code called module. Next, software requirement specification. It is the second slide regarding to software requirement specification. So in this, it serves several goals depending on who is writing it. So now the very important question raised in our mind, that who write actually the software requirement specification. Actually a person, but person maybe a customer or maybe a programmer. So both can write SRS report. First, the SRS could be written by the client or the customer of a software. So SRS report could be written by the client. And second, the SRS could be written by the developer of the system. So both the developer and the client both are able to write SRS report. But there is a little difference between these two types of reports. The first case, SR is used to define the need and expectation of the user. So when a customer or a client write a SRS report, he basically aim to, or he basically used SRS report to define the need and what is his expectation, um, of the what is his expectation regarding to a particular software is a part of SRS report. But when a developer write SRS report, then um, it serves as a contract document between customer and developer. So then it is a part of contract between a customer and a developer. So it is very much familiar, formal rather than previous one, comparison to previous one. So when SRS report is written by a developer, then it serves as a contract document between customer and the developer. So these are the some characteristics of a good SRS. There are many characteristics of good SRS. Uh, First is modifiability. It can be modifiable. Nothing is permanent in SRS report. If certain changes, if customer wants certain changes in SRS report, then it is also possible. So we can say that it is modifiable. Verificability. Verificability means when SRS report prepared, then after that customer verify that SRS report is according to his needs. And some other points are correctness, completeness, high level of abstractions, and this is understandable by the customer, obviously basic thing. Design independence, and it is design independence means that uh, SRS report basically is a documentation of requirement of a software. So it is not depend upon the design, it is actually depend on the requirement of a software. Then testability and unambiguousness, consistency, and finally is testability, traceability. So these are the some important points regarding to a characteristics of a good SRS. So now next slide. Next point is SDLC. SDLC basically refers for system development life cycle or software development life cycle. A software has certain life cycle it should be followed to maintain a good quality of software. So this there is a diagram which represent the software development life cycle or system development life cycle. First phase is requirement analysis. So first part is requirement analysis. First of all, requirement, if a person or a developer know about what is the requirement of the customer, only he can able to deliver a good quality of software. So first point is requirement analysis. Second is defining the requirement. Third is designing. After then a design should be prepared according to that definition. After that coding, and after that testing, and after that when testing is completed, after then deployment of software, and finally the maintenance. So let us take them one by one. First one is phase 1, planning and requirement analysis. So first phase is, that is stage number 1 of SDLC, is planning and requirement analysis. So the senior member of the team perform it with input from the stakeholder and the domain experts. Planning for the quality assurance requirement and identifications of the risk associated with the project is also done at this stage, and business analysts and project organizers set up a meeting with the client to gather all the data, link what the customer want to build, what will be end user, and what is the objective of the project before creating a product. A core understanding or a knowledge of the product is very necessary. So in short, we can say that planning and requirement analysis is basically analysis of the requirement of to develop a good quality of software according to customers needs. So basically a software engineer interact with customer, and basic aim is to collect requirement after discussion, after a long discussion to customer, that what he or she actually wants, and after core understanding or knowledge, product um, requirement analysis requirement analysis of the product is done. So in this very important part is feasibility study. Feasibility study means that whether a software is feasible or not. So after taking the requirement, software engineer wants feasibility studies. Study basically is of three types. First one is economical feasibility, second is technical feasibility, and third one is operational feasibility. So it is a very important part of requirement analysis. For example, if a customer wants that particular type of software, he wants to made within 1 lakh, and actually the cost of that product or software is more than 1 lakhs after estimation, then then a software programmer says that it is not economical feasible. Economical feasibility is not there. And second is technical feasibility. If a particular type of software can be designed on a particular type of software, we can say that Java or .NET framework, then and he wants and customer wants it on Python, then we can say that it is not technical feasible. And third one is operational feasible. Some type of operations cannot be maintained or um, cannot be a part of, if a software, then we can say that it is that the software is not operational feasible. So this is the requirement, is all about planning and requirement analysis. Planning and requirement analysis basically concerned with the requirement requirement detailed analysis of requirement. Only after that a software engineer can say that this project or the software is he is able to design a particular type of software within a particular time limit. Then this is defining requirement after stage 1. requirement analysis of the requirement, different types of requirement. He defined the requirement, what type of software, how many persons he want to design a particular type of software, or what are the hardware requirement of a software. So these all are the part of defining requirement. So once the requirement analysis is done, the next stage is to certainly present the document in software requirement and get them accepted from the project stakeholder. And this is accomplished through SRS. So we can say that SRS is a part of defining requirement. Stage 2. Now it is a very important question. SRS is already discussed in our previous slide. So SRS is a part of defining requirement. Next is phase third, designing of a software. Designing, we can say that it is the blueprint of a software. So after defining the software requirement, then design of the software. This is the stage 3. In this stage, our next phase is about to bring down all the knowledge of the requirement analysis and design of the software project. This phase is the product of the last two kinds of inputs. So in this, a blueprint of the software can be designed. So it is all about designing of the software. Next is coding, developing the project. It's also called the coding. In this program, different programs of software, code of the software, um, software code is written in this part of SDLC, system development lifecycle, also called developing this project. So in this phase, the SDLC, the actual development begins. So actual development begins in this phase, and it is the most important part of SDLC, and the programming is built. So in this part, programming is built. It is basically the implementation of design. So whatever is the design, according to that particular design, coding has to be done. And developer have to follow the coding guideline. There are particular basically guideline, and every developer should follow these guidelines, which is described by the management and programming tools like computer interpreter, debugger, etc. So this is developing the project is a very important part, or we can say that it is a coding section in which code or program uh, according to design are written in this part. And next is testing. Testing is a very important part, and actually it takes a very long time in comparison to coding part. So what is testing? Testing is basically a execution of program in intent to find out an error. It's called the testing. If we execute a program or a software and our intention is to find out an error, somehow our intention is to find out an error, then we can say that it is a testing. So testing is basically execution of a program in intention to find out an error. Once code is written, then after that our aim is to find out an error, and different person find out an error for, and developer also play a role of tester, and there are some other tester who are not part of developing the software or developer team. So testing is basically execution of a program in intent to find out an error. So after the code is generated, it is testing against the requirement to make sure that the product are solving the needs addressed and gathered during the requirement stage. And there are many types of testing. These are some of them are alpha testing, beta testing, black box testing, white box testing. These are discussed later on when we discuss models of software development life cycles. And stage 6 is deployment. So now our software is almost finished. um, Written work is almost finished here. Now if we want to deploy a particular software to the client, then this is stage number 6, that is called the deployment. And deployment says that once the software is certified that no bugs or errors are stated, then it is to deploy to the final customer. Then based on the assessment, the software may be released or as it with the suggested enhancement to the object segment. And after that, maintenance. Once the software is deployed to the final to the end user, it doesn't mean that our work is over. After that there is an stage that is called the maintenance. Now maintenance work start at that point of time, and actually there are four types of maintenance: adaptive, corrective, preventive, and perfective. These are the different types of percentage of maintenance. So let us take a quick revision of all this. Adaptive maintenance is basically is the implementation of change in a part of the system which has been affected by a change that occurred in some other parts of the system. In future, if we change some other part of your system and a system or software, and it basically affect the functionality of another part or program of a system, then this type of maintenance, to overcome this type of difficulty, there is a maintenance called the adaptive maintenance. And the second one is preventive maintenance. So preventive maintenance involve performing activities to prevent the occurrence of error. So to prevent, it involves the performing activities to prevent the occurrence of an error. Third is perfective, and basically it deals with the implementing a new change or user requirement. So it basically focus when user requirement change according to new circumstances or new conditions. After some time, if customer says that these are these are some other functions which should be a part of software, then this type of maintenance can be covered up using perfective maintenance. And so this is all about software development life cycle. These are the basic terminology regarding to software engineering. In our next lecture, we are going to we will discuss about different software models. So these are the different software models by which a software can be designed. These are waterfall models, RAD models, spiral models, V model, increment model, agile model, or iterative model, and then last one is Big Bang model. In our syllabus there are Big Bang model is not a part of our syllabus, so rest all are the part of syllabus of class 12th IP. Waterfall model, RAD model, spiral model, V model, incremental model, and agile model. I hope you like this video. Thank you very much.